Hello and welcome. In this video I'll be talking about compound interest. So first let's have a short review of simple interest and the formula that we use to calculate simple interest. So to calculate simply the interest of simple interest, we'll take I equals P, R, and T. And as a reminder, I there stands for interest. P is principal, so that would be the amount that you invest or put aside in a savings account, for example. R is a rate, the interest rate, and T is an amount of time. So let's say that you have $1,000 to put away, and you find an account that pays 5% interest, and you feel that you can leave this alone for let's say a period of 5 years. And you want to know how much interest you'll earn. So to find the interest, we'll take the $1,000, that's our principal, times the interest rate, which I'm going to convert to a decimal, so this is going to be 0.05, and then the amount of time is 5 years. So that's going to be, 1 second. We've got 5% of 1,000 is 50, and 50 times 5 is $250. So the interest rate there, I thought I was going to need my calculator, but I don't. The interest is $250. So after 5 years, you'll have your principal plus your interest. In other words, you'll have your original $1,000 plus the $250 you've earned. And we say that this is the amount that you'll have, after a certain amount of time. Another way that you can write this formula for A is A equals your principal plus interest, but I already have a formula for interest, which is PRT, and then sometimes we'll factor out this P and say 1 plus RT. So this is the simple interest formula. However, many investments earn compound interest, and to show you how that works, let's say that we have $1,000 to invest, the same as before. We earn 5% interest, but in this case, the interest compounds annually. So at the end of each year, any interest that we've earned basically will be added to our principal, and we'll start earning interest on that amount too. So let's say, look at this, how this would work over the course of maybe 5 years. So I'm going to have a starting amount. Let's see. I'm going to just change this to a start. We're going to add interest, and then we'll end up with a certain amount. So at the beginning of the first year, or in our first year, we have $1,000, and we earn 5%. So that's $50. So at the end of the year, we're going to add the $50 that we earned to our original amount, and we'll have $1,050. Now in the next year, we'll take that $1,050 and earn 5%. So 5% of 1,050. So I'll take 1,050 times 0.05, and we're going to earn $52.50. So we'll earn more in the second year because we're also earning interest on this $50. That was the interest from year one. So when I add the interest to the amount I already have, I have $1,102.50. So in the third year, I'm earning interest on not $1,000, not $1,050, but on a little over $1,100. So I'll take 1102.5 times 0.05, and in this year I'll earn interest of $55.12.5. So adding that to what I already had, so plus 1102.5, I now have $1,157 and almost 63 cents, so 0.625. I'll carry that down, 1157.625 times 5%. So in this year, I'm earning $57.88. And I'm just going to go ahead and leave this decimal 0.88125. So plus my 1157.65. And I end up with 12.1215 and then 0.50625. The next year I had 5% on that, which is $60.77 and some decimals, plus the 1215.50625, and our final amount is $1,276.28. And this time I'm just going to round to the penny. Now, how does that compare? So, with compound interest, even if it just compounds once a year, I end up with $1,276. Now remember, with simple interest, I would have $1,250 and no change. So I'll have about $26 and some change more after just 5 years. Now, to calculate compound interest, you don't have to do this every time. Make a table and find your ending amount. There's actually a formula that we can use for compound interest, and I'll just write down the formula. So we still use A for the amount. That's how much you'll have at the end of your savings period. P is our principal or starting amount. 1 plus R over N, and I'll explain what N is in just a moment. And this is raised to a power of N times T. N is the number of times interest is compounded each year. So keep in mind, for instance, if you want to say semi-annually, then N would equal 2. Or if it was quarterly, then N would equal 4. Monthly, then N would be 12. For daily, you'll have to follow instructions. Sometimes people will use 360. Other times people will use 365, and I guess there would be scenarios where you might use 366. So just follow directions on which of these you would use. It's not going to make a big difference in the short run. However, if you are leaving an investment alone for a long period of time, there might be a growing difference between these two. I'm going to mostly use 360. Of course, if it's just annually, then N equals 1. So let's see. Using N equals 1, let's show how that we can match this number using this formula. So the amount that I earn will equal my principal, which was $1,000. My interest rate was 5%, so 0.05. And I'm just saying that this is one time a year that it compounds. And we left it alone for 5 years, so 1 times 5. So for the calculation, I need to take 1 plus 0.05 over 1, which is just 1.05. And then 1 times 5, which is just 5, and that'll be multiplied by 1,000. So 1.05 raised to the 5th power, multiplied by 1,000, and we get $1,276.28. The same answer I got here when I kind of just made this table and looked at year by year how much I have. This formula certainly would be really a lot more handy if you wanted to say, well, what's going to happen maybe 20 years from now? So I could say 1,000, 1 plus 0.05, and this would be to the 20th. So again, my N value here, I'm just compounding annually. So I would take 1.05 to the 20th power, multiply that by 1,000, and after 20 years, you would have $2,653.30 in the account. That's if you're compounding annually. So let me show you what happens with some different values of n. So I'm going to use the same starting amount. So my principal is still $1,000. Let's use the same interest rate, 5%, and the same time period as I did in the last example, so 20 years. But instead of compounding just annually, let's say that we do it monthly. So our n would be 12. So again, my formula is A equals P times 1 plus R over n, and then this is to a power of n times t. So to find out how much I will have at the end of my 20 years, I'll take $1,000, 1 plus, this would be 0.05, and now this time, since I'm compounding monthly, the denominator is 12, and then I have 12 times 20 in the exponent. So 0.05 divided by 12, that's 0.004 and some change. Add 1, and then this gets raised to the power of 12 times 20. So I'm putting parentheses around that, the 12 times 20, evaluating that, and it's 2.7126 times the $1,000 principal, and I end up with 27, 12, and 64. So when I compound monthly, I end up with over $2,700. Now, this is a reminder, compounding annually, we had $2,653. So a good $50-some extra if we compound monthly. You might want to say, well, comparing some accounts, which is better? Let's say you have a choice between account A, where you earn 5%, and that's compounded yearly, or you could earn with account B 4.5%, but it's compounded, let's say daily. So which of those is going to be better? Now, if this was simple interest, there's no question 5% is better than 4.5. But let's see what kind of difference the compounding makes, yearly and daily. If this is so for both of these, let's say that we have 30 years, and we'll pick an investment amount. Let's say that you have, what if you just had $100? That'll be a nice, easy amount to calculate. So again, I'm going to use for both of these, A equals P 1 plus R over N times NT. So for account A, what's going to happen? The amount that I have is going to be my $100. That's my principal, 1 plus R, so I'm earning 5%, and it's compounding yearly. So that's just a 1 in the denominator, and then N times T is going to be 1 times 30. So essentially, I need to take 1.05 to the power of 30, and then multiply it by my 100. And so I'll end up with $432.19. In account B, let's see, I'll still start with my $100, and I'm just going to earn 0.045, but it's compounding daily. We're going to use 360 here, and then that's going to be 360 times 30. So 0.045 divided by 360 plus 1 raised to the power of 360 times 30 and multiplied by 100. And so with this option, I'll have $385.71. So the higher interest rate beats out the more frequent compounding in this example. So that's just a nice way. And really, as long as I was using the same amount as my initial investment in both, just if I want to see which one's going to outperform, it wouldn't matter. This one's always going to outperform as long as I start with the same principle in account A or account B. Okay, so let's say that we want to think about this in the sort of in reverse, and we don't necessarily say that we have a certain amount we're going to start out with, but rather we have a goal. So maybe you want to make sure that you have $50,000 in 20 years. And you know that you're going to be able to earn around 7% interest, and you found an account that compounds semi-annually. So in other words, n equals 2. And I want to know, so how much do I need to invest now in order to meet this goal? So my formula for compound interest can be rearranged so that it's solved for p. So if I divide both sides by this, I can say that p equals a over 1 plus r over n to the nt. So using this formula, I'll take 50,000 divided by 1 plus, my interest rate is 7%, so 0.07 over n, which is 2, and n times t is 2 times, and I've got 20 years. So let's say 0.07 divided by 2, and add 1, and raise that to the power, 2 times 20 is 40, and I need 50,000 divided by that result. So I would need $12,628, and I'm going to round this up, and so that'd be 63 cents. I'm rounding up because if I round down, I may fall just a little bit short of my goal. So I'm going to say 63 cents here. All right, so that's the formula for compound interest, and also we looked at two different versions of that formula. One where I know the principal, and I'm trying to find how much I'll have accumulated, including my initial investment, at the end of a certain time period. And in the other, I'm saying, okay, here's my goal. I want to end up with a certain amount. How much do I need now? So for this reason, this amount is sometimes called the future value, and this is the present value. So I would need $12,628 now in order to end up with $50,000 in the future. All right, I hope that helps with your understanding of simple interest, and the focus here was really on compound interest. I'll see you next time.